Question level 1. Here are some circles and axes, or scientifically speaking, here is a two-dimensional dataset. Can you find a line that has only axes on one side and only circles on the other side? Yes, you can. This, for example, is 1. If you can find a line like that, that means you're a genius. And that also means, scientifically speaking, that the dataset is linearly separable. Question level 2. What is a mathematical way to tell if any point is above or below this line? For that you will need to find the equation of the line. One possible way for that is that you can get its slope first, which is also known as gradient. So let's take this point, P1, its coordinates are x1, y1, and since that's where the line intersects with the y-axis, x1 will equal to 0. And P2, its coordinates are x2 and y2, and the line intersects there with the x-axis, which makes y2 equal to 0. And the slope in general equals y2 minus y1 divided by x2 minus x1, which in this specific case is minus y1 divided by x2. This tells how steep the line is, but it doesn't tell where the line is positioned relative to the x-axis. To clearly define a line on the coordinate system, I also need to know where it crosses the y-axis. That's again y1. So there it is. For every y value of the line, I can say that y equals minus y1 divided by x2 times x plus y1. That would be the equation of the line. And back to the original question, now if the value of the coordinate point's y value is smaller than the value of the expression on the right side, then the point is below the line, and if it's larger, then the point is above the line. Question level 3. What if I keep adding axes and circles to this dataset regardless of where your line is? Then what would be the best way to modify the gradient and the position of the line so that it still separates the circles and the axes as effectively as possible? How would you decide if the line needs to go a little bit up or down, or it should just stay as it is? What you could do then is implementing a perceptron and train it, and then it will do the job. What is a perceptron and how to build one? That's what this episode will be about. To implement a perceptron, first I'm going to explain its structure, starting with the same line, this time with specific numbers. So this point here is 0, 3, this one is 4, 0. That would make the gradient minus 3 over 4, and y1 is 3, so this will be the equation of the line. And I reorganize this equation so that there will be 0 on one side, and I can quickly check for P1. It will be 0 plus 12 minus 12, which is 0. And for P2, it will be 12 plus 0 minus 12, which is 0. Looks okay. And if I was a perceptron, and let's say I get 1, 1, then I go through this equation. 3 plus 4 minus 12 equals minus 5. So I would know that this point is below the line, while for the 3, 2 point, the result would be 9 plus 8 minus 12, that's 5. That's more than 0. So that point is above the line. And then these points, P3 and P4, would be classified differently. And that's exactly how the perceptron is doing the classification. I grab this equation and write it in a little bit more general form. Here the 3 becomes omega 0, x is x0, 4 is omega 1, y is x1, and minus 12, that becomes a b, a so-called bias, and 1 is constant 1. That's what the bias is always multiplied with. So this is the perceptron version for the separating lines equation on a two-dimensional dataset. And let me illustrate this in a prettier way. The x values are the input values, the omegas are the so-called weights, and this sum means the weighted sum of the input values plus the bias. That's exactly what you can see up there. And in the previous picture I showed that if x0 is 1, x1 is 1, then using these weights and this bias, the output here would be minus 5. And if x0 is 3 and x1 is 2, then the output is 5. These were the examples about a minute ago. But if the perceptron's job is to classify the data, meaning to decide if it's above or below the line, it would be enough to produce only 2 different outputs. Let's say minus 1 if it's below and 1 if it's above, or also if it's exactly 0. That's one of the reasons that the perceptron has one more step before its job is finished, a so-called activation function. There are several different ones. One of the easiest one is the one that does what I just said, and it's called unit step. So a quick recap of the Perceptron's classification before implementing it. I need to get the weighted sum of the input values, add the bias to it as well, then the result goes through the activation function, and finally I get the output. And one last thing, now I have only x0 and x1. Two input values means that it's about a two-dimensional coordinate system, if you want to visualize it. Adding an x2, that would try to find a separating plane in a space instead of just a line, and every additional input value would mean one extra dimension, which is very hard to imagine, so just knowing about it is more than enough. So with this picture in your mind, let's go to VS Code. I have these other files here, but I won't need them in this episode. I create a new file instead, perceptron.js, and create a new class there where the constructor will take a size variable, which refers to the number of the inputs the perceptron will have. As for properties, there will be an inputs array, a weights array, and a bias, which I set to -12 first, because I want to test this perceptron with the same numbers I used in the coordinate systems example. Later it will be a random number between -1 and 1. To test the inputs, I create a setInput method, which takes an array of numbers. First checks if the input array's length is the same as the perceptron's size. If it is, then it sets the input's elements to the ones that came in the argument. If the size is wrong, then I just write a message on the console. And I copy and paste this method and rewrite it to set weights. It will do exactly the same, but with the weight array, although this is again just for testing, because the weights, they are supposed to be also random numbers between -1 and 1, just like the bias. Once I have the inputs array and the weights array, I can create a weighted sum method, iterate through the elements of these two arrays and multiply the ones with the same index together, and finally return with the result. After the weighted sum is there, the next step, that would be the activation function, but before implementing that, I would like to output the result so that I can see if everything works so far the way I hope. So I will have a setOutput method, which simply returns with the this.weightedSum. And I test it with the same numbers I used for the examples. I need to import this perceptron.js in the index.html file, and then I can go to the console, open the developer tools in the browser. There I can create a perceptron with the size of 2, set the inputs first to 0 and 3, the weights will be 3 and 4, the bias I set it to -12, and I call the setOutput method, and the results should be 0. If I change the inputs to 1, 1 and run it again, then it's -5, just like before, and finally the last one I tried was 3, 2. The output for that was 5. All good. Now I feel more confident to implement the activation function, which simply gets an argument, and if that argument is smaller than 0, then the method returns with -1, otherwise with 1. And it will get called in the setOutput method after getting the weighted sum. Yeah. So I quickly try it again, although now probably won't be any surprise here. Now instead of 5 and -5, I should get 1 and -1. Yeah, it looks okay. And as I said, the weights will be randomly initialized between -1 and 1. Same for the bias, which also means that I don't need to set the weights method. I can delete it, I only put it there for testing. And that's it. This would be a working perceptron that I can use as a building block for the neural network. It can do classification correctly if the weights are proper. Now, if they are not proper, then the perceptron needs to be trained. That means that its weights need to be modified to provide more precise classification outputs. How to do that? That would be the answer to the question level 3 from the intro, but that's something I will explain later. Now for the first round, having a perceptron implemented is enough. Next I will combine several perceptrons together, then I will end up having a so-called multi-layer perceptron.